In this session, we are going to discuss about the rate of a chemical reaction. In simple words, rate of a reaction means the speed at which the reactants are converted to product. Now, let us consider a reaction of the type R gives P. As you all know, R is called as the reactant, R is the reactant and P is the product. During the progress of the reaction, the reactant R is consumed continuously and product P is formed. In other words, the reactant R disappears from the reacting vessel and the product P appears in the reacting vessel. That is, the concentration of the reactant goes on decreasing and the concentration of the product increases. Let me explain this to you very clearly. Let us assume that these are the reactant molecules. I have taken the reactant in the reacting vessel and these are the reactant molecules. Once the reaction starts, what happens is the reactant molecules, they get converted to product. The reactant molecules, they get converted to product. That is, during the progress of the reaction, you can notice, or you yourself you can tell me what will happen to the reactant molecules and what will happen to product. You see, the reactant molecules are consumed continuously to form product, or the concentration of the reactant decreases and the concentration of the product increases. Now let us assume that at a certain time T1, the concentration of the reactant in the reacting vessel was R1. This is the molar concentration of the reactant. At the same time, the concentration of the product was P1. Now, the reaction continues after a certain time T. Let us assume that after a certain time T, what happens? Most of the reactants are converted to product. That is, more and more products are formed. Now you see, after a certain time T, let us say now at time T2, the concentration of the reactant is not R1. It has changed. It has decreased. So now at time T2, let us assume that the concentration of the reactant was R2 and that of the product was P2. Now, tell me, what is the change in concentration of the reactant? The change in concentration of the reactant is R2 minus R1 is the change in concentration of the reactant, right? If it was 5 molar, then if it has become 2 molar, what is the change? You find it, how you find the change? That is 5 minus 2, that is 3. So here also the change in concentration of the reactant is R2 minus R1. What is the change in time? The change in time is T2 minus T1. You know, mathematically this can be written as delta R. That is the change in concentration of the reactant. T2 minus T1 can be written as delta T. That is the change in time. Since the concentration of the reactant goes on decreasing, we put a minus sign here. So minus sign indicates that during the progress of the reaction, the concentration of the reactant decreases. Similarly, let us take the change in concentration of the product. That is P2 minus P1 by T2 minus T1. This can be written as delta P by delta T. Since the concentration of the product increases, we put a plus sign. Now, how you will read this? This is the change in concentration of the reactant over a certain time interval, that is T2 minus T1. This one, change in concentration of the product over a certain time interval. Since we are talking with respect to time, we can also use the term rate. In terms of rate, you can read this as, since during the progress of the reaction, concentration of the reactant decreases, we can read this as the rate of decrease in the concentration of reactant. This is rate of increase in the concentration of the product. Now listen carefully. The rate of decrease in the concentration of the reactant or the rate of increase in concentration of the product is called as the rate of a reaction. In general, let us assume that delta X is the change in concentration of the reactant or product. Remember, you can measure the rate of a reaction with respect to any one of the reactant or with respect to any one of the product. For example, if we have a reaction of the type A plus B gives C plus D, then you can measure the rate of this reaction either by taking the change in concentration of the reactant A, or by taking the change in concentration of the reactant B, or by taking the change in concentration of the product C or with respect to D. That is, you can measure the rate of this reaction with respect to any one of the reactant or with respect to any one of the product. So what I am doing is, I will assume that this delta X is the change in concentration of any one of the reactant or any one of the product, and delta T is the change in time, that is the time interval. Now delta X by delta T is called as the rate of a reaction. So delta X by delta T, how you will read this? This is the change in concentration of any one of the reactant or product over the certain time interval is called as the rate of the reaction, is called as the rate of the reaction. Now, do you think that this is the actual rate of the reaction? That is, delta X by delta T will give you the actual rate of the reaction? No, this is not the actual rate of the reaction. This is called as the average rate of a reaction. Then how to find the actual rate of a reaction? You all know that during the progress of the reaction, the concentration of the reactant goes on decreasing. Every second, the concentration of the reactant decreases. So what you must do is, in order to find the actual rate of a reaction, you must take the change in concentration of the reactant or product for a very small time interval. That is, for a infinitesimally very small time. When you take the change in concentration of any one of the reactant or product for an infinitesimally very small time, then you will get the actual rate of the reaction, and we call it as the instantaneous rate of the reaction. Instantaneous rate gives you the actual rate of the reaction. When you measure the change in concentration of the reactant or product for a large interval of time, that will give you the average rate. But when you measure the change in concentration of the reactant or product for a very small time interval, that will give you the instantaneous rate. Let me explain this very clearly to you by taking an example of average speed and instantaneous speed. Let us assume that you are driving a car from place A to place B. Place B is 240 kilometer away from place A, and you took 4 hours to cover 240 kilometers. Now, to cover 240 kilometer, you took 4 hours. Now, how to calculate the speed of the car? You know, speed is calculated using the formula speed is equal to distance covered by time taken. Distance covered by time taken. What is the distance covered? 240 kilometer. What is the time? 4 hours. So what is 240 by 4? It is 60 kilometer per hour. So 60 kilometer per hour. Now my question for you is whether 60 kilometer per hour was the actual speed with which you were driving, whether that is called the actual speed of the car, whether the speedometer of your car, you know the speedometer, in all vehicles there will be a speedometer which is used to measure the instantaneous speed of a car or any vehicle, right? My question is whether the speedometer of your car was showing 60 kilometer per hour throughout the journey from A to B. No, depending on the condition of the road, traffic, weather, etc., the speedometer of your car was showing varying speed from 10 kilometer per hour to 120 kilometer per hour or 140 kilometer per hour. Am I right? Now, let us assume that you started your journey at morning 10 a.m. At 10:30, when you saw the speedometer of the car, the speedometer was showing a reading 80 kilometer per hour. At 11 o'clock, when you saw, it was showing 40 kilometer per hour. At 11:15, 90 kilometer per hour. At 11:45, 20 kilometer per hour. Right? Now you tell me whether 60 kilometer per hour was the actual speed. Let me assume that one of your friend called you at 10:15 and asked you, hey, where are you, man? What are you doing? And you said, I am going to some place B, man, and I am driving the car. Then your friend asks you, at what speed you are driving? Then whether you will say it is 80 kilometer per hour or you will tell him 60 kilometer per hour. Definitely you will tell him 80 kilometer per hour. Then what is the actual speed? Actual speed is 80 kilometer per hour at that time instant. That is at 10:15. At 10:45 it was 40. At 11 o'clock it was 90. At 11:45 it was 20. So when you calculate the speed, if you calculate it for a large interval of time, see like this, for a large interval of time, the speed what you calculate will be called as the average speed. But when you calculate the speed for a very small interval of time, or let us say almost at that instant, see, at that instant at 10:15 the speed was 80 km per hour, at 10:45 it was 40 km per hour. So the speed at that instant gives you the actual speed and we call it as the instantaneous speed. Is this point clear to you? Then similarly, in case of average rate and instantaneous rate of a reaction, when you calculate the rate of a reaction for a large interval of time, then it is called as the average rate. But when this interval is very small, t1, t2, see, the interval is very small, that is almost at that instant. So when the time interval is small and when you take the change in concentration of the reactant or any one of the product for a very small time interval or for at that particular time instant, then we call it as the instantaneous rate. So Average rate is the change in concentration of any one of the reactant or product over a certain time interval. Instantaneous rate is the change in concentration of the reactant or product at that particular time instant or for a very small time interval. So this instantaneous rate gives you the actual rate of the reaction. So whenever in this chapter we talk about rate of a reaction, we will be talking about instantaneous rate only. Okay, is this point clear to you? Now I will write these definitions of average rate and instantaneous rate for you. If you want, you can take down. Okay. Yes, average rate, it is defined as the change in concentration of any one of the reactant or product over a certain time interval. Instantaneous rate is, it is defined as the rate of change of concentration of any one of the reactants or products at that particular instant of time, or you can also define it as, it is defined as the rate of change of concentration of any one of the reactant or products over a very small time interval. See here, over a certain time interval, here it is for a very small time interval. So then it will be called as instantaneous rate. So when you measure the change in concentration of reactant or product for very small time interval, instantaneous rate. For a very large time interval, it will be called as average rate. So we will be talking only about instantaneous rate. So whenever we use the term rate of a reaction, here afterwards, we will be talking only about instantaneous rate. So before that, for a reaction of the type R gives P, then you can measure the rate of this reaction, the average rate of the reaction with respect to reactant or with respect to product P. Whether you measure with respect to any one of the reactant or with respect to any one of the product, the rate of a reaction will remain same. The average rate of a reaction is denoted by the symbol delta X by delta T. So with respect to R, we write it as, whenever we write with respect to reactant, we must put the minus sign, R divided by delta T. For product, it is plus delta P by delta T. We use this delta for a larger change, that is when we measure average rate. Okay, when the change is very small, for a very small change we use the symbol D. So for instantaneous rate, we write it as, or we represent it as dx by dt. See, dx by dt. Delta for larger change, for a very small change we use the symbol D. So this is the instantaneous rate of a reaction. So whenever we write dx by dt, you must understand that we are talking about instantaneous rate. So with respect to product, we write it as minus d r by dt. So this is called as instantaneous rate of a reaction. This symbol represent the change in concentration of the reactant with respect to time. This also represents the rate of disappearance of the reactant R. So if you are asked to write the expression for the rate of disappearance of the reactant R, then you must write it as dx by dt is equal to minus dr by dt. If you are asked to write the rate of appearance of the product P, then we write it as dx by dt is equal to plus dp by dt. This term represents the rate of appearance of P. This is the rate of disappearance of R, or the rate of decrease in concentration of the reactant. This is rate of increase in concentration of the product. Now, what is the SI unit of the rate of a reaction? You see, the numerator term is what? The concentration term. Denominator is time. What is the unit of concentration? It is mole per liter or mole per dm cube. Denominator is time. So SI unit of time is second. So what will be the SI unit of rate of a reaction? It will be mole per liter per second. So SI unit is mole per liter per second, or we can write it as mole per dm cube, mole per dm cube per second. This is the SI unit of rate of a reaction. Hope you understood the difference between the average rate and instantaneous rate. And remember, instantaneous rate gives you the actual rate of the reaction, and this is how we represent the instantaneous rate of a reaction with respect to reactant or product. Is this point clear to you? Yes. Next, we will talk about the modes of expressing the rate of the reaction. Next, the modes of expressing the rate of reaction. There are two ways in which you can express the rate of a reaction. First, you can express it either by taking the rate of decrease in concentration of any one of the reactant, or by taking the rate of increase in concentration of any one of the product. So these are the two ways in which you can express the rate of a reaction. For example, let us consider a reaction of the type A plus B gives C plus D. Here you must note down that the stoichiometric coefficient of all the reactant or products are equal to 1. What do you mean by stoichiometric coefficient? The numbers that you use to balance a reaction, they are called as stoichiometric coefficient. Here you see the stoichiometric coefficient of A is 1, B is 1, C is 1, D is 1. So in this case, the stoichiometric coefficient of all the reactant and product is equal to 1. In this case, how to express the rate of a reaction? So the reaction rate can be expressed in two ways. Either by taking the rate of decrease in concentration of reactant A, or rate of decrease in concentration of reactant B, or rate of increase in concentration of product C, or the rate of increase in concentration of product D. That is, you can express the reaction rate either by taking the rate of decrease in concentration of any one of the reactant or by taking the rate of increase in concentration of any one of the product. That is, with respect to A, how you can express rate? Instantaneous rate. I have told you again and again, we will be not using the term instantaneous rate. When we say rate of a reaction, it is instantaneous rate, and you will represent it as dx by dt. So with respect to A, you will write it as minus dA by dt. With respect to B, it is minus dB by dt. For product, you must take plus dC by dt plus d by dt. Whether you measure the rate with respect to reactant A, or with respect to B, or with respect to C, or with respect to D, the rate will remain same. Okay, and what does this term indicates? this term indicates the rate of disappearance of A. So rate of disappearance of A is written as minus dA by dt. Rate of disappearance of B, this is rate of appearance of C, rate of appearance of D, or this is the rate of decrease in concentration of A, rate of decrease in concentration of B, rate of increase in concentration of C, this is rate of increase in concentration of D. Okay, now if we have a reaction of this type, let us say A plus B gives 2C. In this case, you see the stoichiometric coefficients are not equal to 1. Here the stoichiometric coefficient of A is 1, B is 1, but C is 2. What does it indicate? The rate of appearance of C or the rate of formation of C is 2 times more than the rate of disappearance of A or the rate of disappearance of B. So the rate at which the A molecule is consumed or the rate at which the B molecule is consumed and rate at which the C molecule is formed, if you see, this is 2 times this. So if you measure the rate with respect to A and rate with respect to C, the rate will not be same. So what we must do in order to make the rate of a reaction uniform, that is only when the stoichiometric coefficients are not equal to 1, in order to make the rate of the reaction uniform, you must divide the concentration change term, this term, by their stoichiometric coefficients. For example, for this reaction, we write it as dx by dt is equal to minus dA by dt. What is the stoichiometric coefficient of A? It is 1. For B, it is minus dB by dt. For C, it is plus dC by dt. I said that to make the rate uniform, you have to divide the concentration change by the stoichiometric coefficient in the balanced equation. For C, stoichiometric coefficient is 2. So you have to divide this term by 2. So it is 1 by 2 dC by dt. Let us try to understand this clearly by taking few examples. Let us take this reaction. N2 plus 3H2 gives 2NH3. In this case, you see the stoichiometric coefficients are not equal to 1. For N2 it is 1, for H2 it is 3, but for NH3 it is 2. So in this case, how you will express the rate? So dx by dt is equal to, what is the rate of disappearance of N2? It is minus d N2 by dt. Let us assume that in a problem they have mentioned that the rate of disappearance of N2 is 3.8 into 10 to the power minus 2 mole per dm³ per second. That means they have given the value of minus dN2 by dt. Similarly, for H2, since the stoichiometric coefficient of H2 is 3, we must divide it by 3. So minus 1 by 3 dH2 by dt. This is equal to 1 by 2 dNH3 by dt plus 1 by 2 dNH3 by dt. So this is how you will express the rate of a reaction with respect to any one of the reactant or with respect to any one of the product. And this is very important for the competitive exams. In examination, they will give you the rate of disappearance of N2 and they will ask you to find the rate of appearance of NH3. Then what you must do? You must write the rate expression. They have given this. You are asked to calculate this. So in this case, what you will do? You will equate minus dN2 by dt is equal to 1 by 2 dNH3 by dt. dN2 by dt is given. You substitute the value. 2 will come here, multiply it. You will get dNH3 by dt. So Okay, in the next class we will take few example problems related to this and we will try to understand this concept. One more example we'll take. 2HI gives H2 plus Hi2. How you will write the rate of this reaction? That is dx by dt is equal to minus 1 by 2 d hi by dt. This is equal to plus d h2 by dt. This is equal to plus d I2 by dt. Okay, here stoichiometric coefficients are 1. That's why we have written it like this. But here it is 2, so you have to divide by 2. Remember, with respect to reactant, always you must write minus. When you write with respect to product, you will write plus. Is this point clear to you? So today in this session, we have discussed about the rate of a reaction, average rate, instantaneous rate, and we are trying to understand exactly the difference between the average rate and instantaneous rate, and finally the modes of expressing the rate of a reaction. Hope all these points are clear to you. This is all for today's session. In the next session we will solve few problems related to this, and we will discuss one of the very important term in this chapter, that is molecularity of the reaction.